Find the following indefinite integrals. So we've got the integral of 1 over x squared minus 4x plus 20 dx. Now here, this cannot be factorised. So if we got a denominator that cannot be factorised, a quadratic, in the denominator, you have to actually complete the square. So as the denominator does not factorise, we have to complete the square. So you need to know how to complete the square. Again, this is a further maths type question. So we've got x squared minus 4x plus 20. What you do is you take half of the minus 4. Okay, there's several ways of completing the square, but this is how I do it. So half of minus 4 is minus 2. Then you write x minus 2 all squared. You've got the plus 20. And the bit that you've added in is going to be minus 2 squared. So minus 2 squared is plus 4. So you've got plus 4 here. You now need to take 4. So the denominator will become x squared, x minus 2 all squared plus 16. So if we now write our integral, original integral, and now rewrite it, I'm just going to swap these two over. 1 over 16 plus x minus 2 all squared dx. By substitution, if you let u be equal to x minus 2, du by dx will be 1, which means that du is equal to dx. So we get the integral of 1 over 16 is 4 squared plus u squared du. Let's write that out again. Okay, this is a standard integral. So the integral of 1 over a squared plus x squared is 1 over a arctan x over a plus c. So this will be 1 over 4, because a is 4, arctan of u divided by 4 plus c, and then putting back the u being x minus 2, you get a final answer of 1/4 arctan of x minus 2 over 4 plus c. Right, the second example, we've got 2 over 5 plus 4x minus x squared. So what you have to do here in the denominator, you need to complete the square for the denominator. So we'll just take the square root sign out for a moment. So we've got, rewrite it as minus x squared plus 4x plus 5 is equal to, sorry. Now, there's different ways of completing the square, but this is how I do it. I'm going to write it as minus bracket x squared minus 4x. The sign would have to change because I'm taking that minus sign, plus 5. And then I would take half of that number, which is minus 2. So I've got minus x minus 2 all squared plus 5. Now I've added in a minus, because the minus sign there, and then this term here, which is minus 2 all squared, which is minus 4. So if I've taken away 4 here I now need to add 4. And then I'm going to rewrite it. 5 plus 4 is 9. I'm going to write 9 minus x minus 2 all squared. So my integral will become, I'm going to take the 2 out, and I'm going to write it as 1 over 3 squared minus x minus 2 all squared. And then by substitution, again, I'm going to let u be equal to x minus 2. Du by dx is 1, which means that du is equal to dx. So that will give me 2 times the integral of 1 over the square root of 9 is 3 squared minus u squared du. When I substitute back in, now this is a standard integral, so 1 over a square root of a squared minus x squared is equal dx is arc sine x over a plus c. So this will be 2 times arc tan u over a plus c, and then putting back my u, I'm going to get 2 arc sine x minus 2 over 3 plus c as my final answer. So this has been a video where you have quadratics in the denominator, where you in fact have to complete the square. I hope you've understood, and I thank you very much for watching.